Alrighty, so let's start 3.1, and this is talking about solving systems of equations by graphing. So you have done this before in Algebra 1. I know it's been a little bit, so I'll remind you. If you don't remember, that's okay. I'll teach you how to do it. So whenever you are doing these, they're asking what are the solutions to these two equations? And the answer is always going to be where the two lines meet. So your answer is always going to be a coordinate. So you must write it as an ordered pair. For example, it'll look something like this: 3, 2. Okay? So there's 3 different methods in order to solve these systems. The first one is graphing, so let's just do it. So letter A, y equals, and then it has that weird bracket thing, and then you have 2 equations. I know it's kind of a weird way to write it, but it's fine. So how do you graph that first one, the top one? Well, both of them are in slope-intercept form, so we just go to +3 for the first one. The slope is -1, so down 1 over 1 a few times. Okay. And then connect them. It's important that you make your lines as straight as possible on this because you're depending upon them in order to see where they intersect with another line. So accuracy is important. Okay, this next one is -2 is the y-intercept, and the slope is 3/2, so up 3 over 2. Okay, and you can see right there where those lines intersect. That coordinate, and this is how you write your answer, would be, what is that? 2, 1. Must have parentheses, must have the comma. Okay, next one. There's a few different ways to graph this first one. Let's just do the good old-fashioned finding the intercepts. And again, I'm doing the top formula. So the x-intercept is when y equals 0. Right, so that would be 2x equals 4. So then your x value is +2. The y-intercept, I can write, would be 2 when the x is 0. So 2 times 0 minus 2y equals 4. -2y equals 4. Divide by -2. So y equals -2. Okay, let's connect those. So 2 on the x-axis, -2 on the y-axis. So let's see how bad this is going to look. Okay, might have to fix that later, but I think it'll be okay. All right, this next one is a little bit different. You could use that same way or that I just did, or I think it's easier just to get the y by itself on this one and add x to both sides. So this would be y equals x plus 6. Okay, so now we have a graph at 6 on the y-axis. Slope is +1. Okay, and it looks something like this. Okay, what do you notice about these lines? Well, hopefully you're thinking they are parallel, right? So remember I said the answer to these is where do they cross? Well, if you know anything about parallel lines, you know that they're never going to cross. So what would be the answer? In this case, it would be no solution. And you will have some like that. So just know if they're parallel lines, it's no solution. Okay, let's graph this one. I have 0, remember, because this is like +0. So your y-intercept is 0, 0. And then the slope is -1/3, so down 1 over 3. Right? Okay, and then the next one, your y-intercept is -4. Then it's +1, so up 1 over 1. So it looks like those lines intersect at the point 3, 1. Okay, the next one, this one's kind of a pain, but that's all right. This is as probably difficult as it gets because they're both in standard form. So I'm going to do the top one first. I'm going to find my intercepts. So the x-intercept would be 2x minus 4 times 0 equals 8. So 2x equals 8, therefore your x-intercept would be 4 divided by 2. The y-intercept is when x equals 0. So you have negative 4y equals 8. So y is negative 2. All right, so I'm going to go ahead and plot that. So 4 on my x-axis, negative 2 on my y. Try to make them look nice. That did not look nice. Try it again. Okay, so now let's do the other line. I'm going to do it the exact same way. So I'm going to find my x-intercept is 3x plus 2 times 0 equals negative 12. So 3x equals negative 12. So x is negative 4. The y-intercept is 3 times 0 plus 2y equals negative 12. 2y equals negative 12 divided by 2. So y equals negative 6. So negative 6 on the y-axis and negative 4 on the x-axis, right? So this is one of the times when it looks like it might not be the best. Okay, let's see. So you can see I'm kind of struggling here. So my points are off. This red line is what I think is off. So this is, I think this red line, let's see if this will let me do it. Kind of. Okay. So as you can see, if I kind of moved it up, that red line was off. So that looks like that coordinate that they intersect is at negative 2, 3. If you're doing this on Notability, the Notability lines like snap into place, so use that. Okay, let's do 2 more. So this one, let's get on the top one, I'm just going to move that x over by minusing x. So that turns into y equals negative x plus 1. So positive 1, your slope is negative 1. Okay. And then it's going to look like something like that. See, I'm already struggling again. Let's try it. Okay. Next line, the y-intercept is positive 4. And it is a slope of negative 1. Oh, look at this. We got another one. Those are parallel lines, therefore there is no solution. Okay, last one. I'm going to convert this to slope-intercept form. So minus 6x to both sides. So then we have 2y equals negative 6x plus 1. Divide everything by 2. So y equals negative 3x plus 1/2. Not the best example, but that's okay. All right, so let's graph the top one. So we have positive 1. And then the slope is negative 3 over 1, negative 3 over 1. Looks like that. Uh-oh, I can see it's going to happen already. So that second line, the y-intercept is 1/2, which is fine. We can do that. But it has the same slope. It's going to be down 3 over 1, down 3 over 1. So what do you notice? This is a bad example. That's what you notice. This example is terrible. Okay, they are parallel lines again, so therefore there would be no solution. All right, that is it. Hope you enjoyed watching. Have a great rest of your day.